Greetings and welcome to the video on sampling distribution. Let me go ahead and get the title of this lecture up on the canvas here. Sampling distribution. So up until this point, we have really only dealt with, in these first 10 modules, one type of distribution, and that is basically just a frequency distribution. And so now we're going to be extending that to this concept of a sampling distribution. So let's just kind of review what we have done so far. So you should be familiar with the concept of frequency distribution. And we're going to build off of this. So let's just recall what that was. A frequency distribution deals with these raw X scores, or I would say X, to this, sub I, X sub I, so every ith raw score that we've randomly drawn from our population. And we did histograms on this, we did, cumulative frequency. You've done lots of different types of graphing and plotting up to this point in time of the class. And so what does this ith raw score mean? Just to kind of review here, if you had every ith person and you had their whatever this random variable x is, let's just say that you're collecting age, that x equals age. And so you get the first person that comes in and you collect their age data, and maybe they are 22. You get the second person and maybe they're 34. You get the third person and maybe they're 18. You get the fourth person and maybe they're I'm going to pick something 40. Take the fifth person and then maybe they're 27. Okay, and then you could just keep collecting. And so basically when I equals 1, the x value, that's the first person in your data set, and their age was 22. When I equals 2, that's the second person in your data set, and their age was 34. And you know this, and we know that we can take and plot these values. We can plot them. You simply, let's just kind of make a plotting surface here. We'll make this one very basic, where you're going to plot your x scores here. Y is over here. Your y-axis here is frequency, and you're going to plot really frequency of what? You're plotting frequency of these x sub I scores, or these raw, each raw ith score on the x variable. Okay, so this would normally kind of be or approach some kind of normal curve. And what does this look like? I mean, we know that we're going to kind of stacking up scores in here, right? These are the frequencies of these scores and so on and so forth. Kind of just draw this out a little bit here. Switch colors. And so what is this one right here? Well, it's this, whatever this frequency is here. We got this many of this particular score. We got this many of this particular score, and so on and so forth. Right, and we can get, if this is in fact a normal distribution, then this point right here would be the mode, or the most frequent, and we could calculate things like, let's just say the mean. So what would the mean here be? Well, the mean is not an xi anymore, it's an x bar, and it is the sum from I equals 1 through the n number of subjects that you have. So this would be down through n here of all the x sub I scores divided by the total n. And where would that be? That would be kind of right here in the middle. If this was normally distributed, it'd be kind of right here in the middle of this largest heap of scores right here, right? So this is like a certain number of scores the same score stacked up on top of one another. So if this was age, 25, that's one person who had 25, that's another person who had 25, another person who had 25, another person who had 25, and so on and so forth. This is how many scores of 25 that you got in your particular sample. And if we can calculate the mean on this, we can calculate, the standard deviation, and again, this is the sum of, the x minus x bar squared divided by, n minus 1. If we wanted to get the standard deviation, it's just taking the square root of s squared. What are all these? All these are sample statistics, descriptive statistics at that. But this is our review point, right? I mean, basically at this point in time, what are we saying? We have only dealt with frequency distribution. This is a quick down and dirty review of frequency distribution, and now what we want to do is extend the concept of a frequency distribution of raw scores on your random x variable, and we want to extend it to the concept of a sampling distribution. So how do we do that? Well, suppose that this distribution here, right here where the asterisk is, this distribution was based on n equals 25, but we drew 25 people and we got this particular distribution where the asterisk is. Now let's do this. Now suppose we put those 25 people back into the population and redraw a new sample of n equals 25. So now we repeat the process, drawing 25 subjects randomly, emphasize that, randomly, from our population. And let's say we do this 4 more times. So in addition to the one that we've already done, again up here, let's do this 5 times. So let's redraw and kind of miniature form that first frequency distribution. So let's say we kind of have our distribution here. This is frequency distribution of raw scores, and this is the first one we did. And here is the x bar of this first frequency distribution, and this is based on n equals 25 folks. We put those 25 folks back into the population and we pull 25 more individuals, calculate their means. We get another frequency distribution, second one. We get a mean of the ages of this sample. This sample is based on n equals 25. Here's the x bar, or the mean for that frequency distribution. We put those 25 back in. Let's do this again. Here's frequency distribution 3. This is based on n equals 25. Where's the mean here? Here's our third x bar. Put those 25 back in. Bear with me here. Here's our fourth frequency distribution. We got n equals 25 here. Here's the mean age again of those raw scores. Put those 25 back in the population. Draw another sample of n equals 25. Here's our fifth frequency distribution. And here is the x bar, or the mean of the age for that fifth one. Now a couple of things here. We wouldn't expect each one of these means down here. So this mean, this mean, this mean, this mean, and this mean. We don't expect all these means to be the same. In other words, x bar for frequency distribution 1 would not be equal to x bar frequency distribution 2, right? Because the individuals that allowed us to capture a mean age here are not the same individuals, at least not all of them, that were in frequency distribution 2. And so we wouldn't expect, therefore, the ages to be the exact same. But each one of these x bars, x bar 1, x bar 2, x bar 3, is in fact a point estimate of what the mean in the population could be. But now what we want to do to extend from frequency distribution to a sampling distribution is now we have values here. Just like we had raw values, raw score values to create a frequency distribution, we can now create a frequency distribution of these 5 mean scores. So I can take this mean score, this mean score, this mean score, the 4th one, and the 5th one, and I can now essentially create a frequency plot of these x bars, not a frequency plot of xi scores, or these of raw scores. So what would this look like? Well, let me just kind of section this off a little bit here. Here's our x, here's our y, and now the y is frequency of x bars. Where over here it was the frequency of the raw scores. Now we're a frequency of x bars, moving over to a sampling distribution. So hopefully here in just a second this is going to make more sense to us. Okay, so we've done this, we've repeated this 5 times. Now we could come over here and we could plot all these scores and say maybe the x bar 1 was here, x bar 2 was the same score, and x bar 3, x bar 4, so on and so forth. But these would create a distribution of scores of x bars, and we call this distribution, this frequency distribution of x bars, a sampling distribution. We call it a sampling distribution because it's based on what? Sampling statistics, or not sampling, but sample statistics. So if you go back over here, sample statistics, what are sample statistics? You've got x bar, you've got s squared, you've got s. So you could take any of these and create a frequency distribution. What was the frequency distribution of the variance from frequency distribution 1 or frequency distribution 2? You could plot the standard deviations of all of these 5. In this particular case, we're plotting the means of all these frequency distributions, and so we call this a sampling distribution of the mean. I'll put that in blue, in a blue box, because we could call this a sampling distribution of the standard deviations. If we plotted the standard deviations from this one, this one, this one, this one, and this one, we could call this the sampling distribution of the variance if we plotted the variance from FD1, FD2, FD3, FD4, and FD5. But in this particular case, we're calling it the sampling distribution of the mean. Why is this important to us? Because if we've only repeated this 5 times, but if we repeated this 10 times, we would expect the mean of the sampling distribution of means, the middle point, we would expect the mean of the sampling distribution of means to approach mu as n goes to infinity. So if we repeated this 10 times, x bar would be a better estimate of mu. If we repeated it 1,000 times, x bar would still get even closer to mu. If we repeated it an infinite number of times, x bar would be, in fact, become mu. Okay? And so the sampling distribution of an infinite number of n equal 25 frequency distributions would have an x bar, and that x bar would in fact be mu. And that is a really important tenet for us to move forward with inferential statistics, is that this x bar is in fact what we call an unbiased estimate of the population parameter. If it wasn't an unbiased estimate of the population parameter, we wouldn't be able to use it and calculate it on our samples and then try to infer any differences between a treatment group mean and a control group mean. We couldn't we couldn't use the mean of those groups to infer any differences that might happen in the population, that might be present in the population. So this is a really important tenet for us to be able to have. Now from this, we need to kind of look at some of the properties of this sampling distribution, and that's what will happen in our next video. So I hope you enjoyed this video. Thanks for watching.